Alright, imagine this. Scientists discover an asteroid the size of a mountain, and it's headed straight for Earth. But don't worry, they say we've got 14 years to plan. Sounds pretty good, right? Plenty of time. Well, not so fast. Here's the thing about space rocks. They don't exactly play by our rules. Even with all the planning in the world, stopping an asteroid isn't as simple as sending Bruce Willis up there with a drill. This isn't Hollywood. This is real life. And in real life, things get extremely complicated. First off, think about the sheer scale of what we're being dealt with here. An asteroid that could cause significant damage is likely to be miles wide, traveling at tens of thousands of miles per hour. It's like a bullet in space, and it's aimed right at us. Sure, 14 years might sound like a lot, but in the world of space engineering, it's barely enough time to even get started. Why is this? Because developing the technology to deflect or destroy an asteroid is incredibly challenging. We're talking about building something that's never been done before, and doing it perfectly. If we miss, or if the solution doesn't work as expected, you might just make things worse. Fragmenting an asteroid could result in multiple smaller impacts, still as devastating, but now spread out across the entire planet. And then there's the question of the deflection itself. By the time we spot an asteroid that's on a collision course with Earth, it might already be too late. Our current deflection systems are good, but they're not perfect, and smaller asteroids or one with a particularly tricky orbit could sneak up on us with far less warning than we would really like. Even if we do spot it early, there's no guarantee we have the resources or international cooperation to mount a successful defense. Blowing up an asteroid might sound like a good idea, but it could take years of negotiation, design, and testing just to get the go-ahead. We've got to convince the world's government to pour their resources, agree on strategy, and execute the strategy flawless. And let's be honest, getting the whole world to agree on anything is already a Herculean task. And let's not forget about what could go wrong. Let's say, for example, we launch the mission and we go to the asteroid. The spacecraft gets there, it lines up its shot, and then it fails. The asteroid's path isn't altered enough, or it breaks into pieces that are still on a collision course with Earth. Instead of one big impact, now we are dealing with a shotgun blast of smaller impacts, not exactly an improvement. Now here's a scary thought. Even if we somehow manage to deflect or destroy the asteroid, the debris could still pose a massive threat. Pieces of the asteroid could rain down on Earth, causing widespread destruction. The skies could literally be raining fire, with fragments creating impacts all over the globe. That kind of scenario would make even the calmest among us wish we just packed up and moved to Mars. Now let's play a little game of what if. Picture this, the asteroid is only partially deflected. Maybe it misses New York City by a few hundred miles, but slams into the Atlantic Ocean. The impact sends a shockwave through the Earth's crust, triggering massive earthquakes and volcanic eruptions. The tsunamis it generates, created by the impact, race towards coastlines of multiple countries, wiping out cities and infrastructures, anything in its path. And as if that wasn't enough, the dust and debris that's thrown up into the atmosphere will block out the sun for a few months, plunging the planet into a sudden and brutal winter. Crops would fail, ecosystems would collapse, humanity would be pushed to the brink of extinction. In a worst-case scenario, this asteroid impact set off a chain of events that could make Earth nearly inhabitable for years, if not decades. Let's not build those doomsday bunkers just yet. There's hope. Engineers and scientists around the world are coming up with innovative ways to defend our planet from such a threat. From kinetic impactors to gravity tractors, there's a whole arsenal of creative solutions being developed. It's like something out of a sci-fi novel, but it's happening right now. It's really incredible, and it's really important to the future of humanity. And here's something really cool. According to a quote from an article over at space.com, these efforts are more critical now than ever before. The more we explore space, the more we need to ensure that we can protect our planet from these kinds of cosmic threats. After all, Earth is our only home, and we've got to defend it, not just for us, but for everyone who comes after us. So, if you're passionate about space as I am, I encourage you to dive deeper into this topic over at space.com, as they have a fantastic article and it breaks down the complexity of asteroid defense and what's being done to tackle it. Their top tier coverage is a must read for anyone who cares about the future of our planet. If you've enjoyed this deep dive into the challenging asteroid defense systems of our planet, make sure to like, share, and subscribe to our channel. We're all about bringing you the latest and greatest from the world of space exploration, and we wouldn't want you to miss a thing. Let's keep our eye on the stars and our feet on the ground, because the universe is way too amazing to be destroyed by a giant rock. Thank you so much for watching. I will catch you in the next video.